Hello students, in this video we are discussing a gate numerical. See the next problem. Consider a sampled signal y of t equal to 5 into 10 power 6 x of t into summation is from minus infinite to plus infinite delta of t minus nts, where x of t equal to 10 cos 8 pi into 10 cube t and ts value 100 microsecond. When y of t is passed through ideal low pass filter with a cutoff frequency 5 kHz, the output of the filter is, options are 5 into 10 power minus 6 cos 8 pi into 10 cube t, 5 into 10 power minus 5 cos 8 pi into 10 cube t, option C 5 into 10 power minus 1 cos 8 pi into 10 cube t, option D 10 into cos 8 pi into 10 cube t. This is asking in the GATE 2002 for 1 mark. So this sample signal is passing through some low pass filter. Cutoff frequency is 5 kilo he given. What is the output is asking. This is a y of t given na. So first calculate y of f, then you will get the more clarity. Then what is y of f equal to? That is 5 into 10 power minus 6 outside. Summation also a constant you can write outside. Summation n is from minus infinite to plus infinite. X of t, let's take x of f. And multiplication will become convolution. Delta of t Fourier transform is also same, but f minus nfs into you have to write, you're getting my point, into you have to write fs. So that constant na fs I can write here. Sorry, 1 by fs, are you getting my point? Into fs, sorry. Into fs only you need to write. Now try to follow. 5 into 10 power minus 6. fs is nothing but 1 by ts. What is the ts value given? 100 microsecond. So into 1 by 100 micro means 10 power minus 6. And here any signal if you convolute with the impulse, same signal will come. That is summation n is from minus infinite to plus infinite x of f minus nfs. What is this value? 5 into 10 power minus 2. Now this we need to expand from minus infinite to plus infinite. So if I start at n equal to 0, what will be there? X of f. Next x of f minus fs plus fs, like and so on, from minus infinite to plus infinite will be there. Now if you see here, what is the fs value is 1 by ts is this. So fs if comes in the numerator 10 power 6 into 100. So 10 power minus 4 comes in the numerator. 10 power 4 means 10 kilo. So first x of f. Next x of f shifted to 10k as well as shifted to minus 10k. But ideal low pass filter is up to 5k means those components are blocking. So low pass filter is allowing only this component. What is the next component? F plus fs. F minus fs. This is x of f plus fs. Shifted to 10k minus 10k. Those are high frequency blocked by the low pass filter because cutoff frequency given up to 5k only. So low pass filter is allowing only x of f component. So now if I write in the final time domain 5 into 10 power minus 2 into x of t. What is the x of t given, sir? 10 cos 8 pi into 10 cube t. Then final answer is 5 into 10 power minus 1 cos 8 pi into 10 cube t. Got my point or not? So now you can see the options. If you see the options, option C is the correct answer. Clear? Simple question. Only you need to know the Fourier transform for this one. Same x of t is x of f. Multiplication is convolution. Impulse also same. but into Fs will come. That is only the difference. Clear? Just I substituted, passed through the filter, whose cutoff frequency is 5K, then output you got. See the next problem. For a bitrate of 8 kbps, the best possible values of the transmitted frequencies in a coherent FSK system are option A 16K and 20K, option B 20K and 32K, option C 20K and 40K, option D 32K and 40K. This question is asking in the GATE 2002 examination for 1 mark students. We already known for a coherent FSK what is the orthogonality condition and what is the best possible values condition. The condition is F1 and F2 should be multiple integers of 1 by TB, which is nothing but N1 into RB. This is N2 into RB, where N1 comma N2 are integers I told. So if you multiply RB with some integer, F1 has to come, with another integer, F2 has to come. Is already given bitrate is 8K. So 8 multiplication table. So if you see the first option, 8 2s are 16. But in the 8 table, 20 won't come. You can observe. Because that N1, N2 should be integer. If 20 is not coming means, I can say first 3 options are ruled out. Because in the first 3 options, 20K is given. See the last option. 8 4s are 32, 8 5s are 40. So 40 and 32 possibility is there. So the best choice will be 32 and 40K. Only the logic you need to understand that for the best possible values for orthogonality, this is the condition. So F1, F2 should be multiple integers of 1 by TB or RB. Both are same. Got my point or not? See the next problem. A signal x of t equal to 100 cos 24 pi into 10 power 3t is ideally sampled with a sampling period of 50 microsecond and then passed through ideal low pass filter with a cutoff frequency 15 kHz. Which of the following frequencies are present at the filter output? Option A 12 kHz only, option B 8 kHz only, option C 12K and 9K, option D 12 kHz and 8 kHz. This is asking in the 2002 GATE examination for 2 marks question. So what are the frequencies are available in the sampled signal? The frequencies in the sampled signal is NFS plus or minus FM, where N is an integer 0, 1, 2, 3, 4, 5 and so on. So what is the first one will be available plus or minus FM. What is the FM value? Is 12K. You can see 24 pi means divided by 2 pi. Next what is available? Fs N value 1. Fs plus or minus FM. Ts value given 50 microsecond. Fs will be 1 by Ts. 1 by 50 microseconds means 20K plus or minus 12K. Next, an integer N value 2. 2 20s are 40K plus or minus 12K. Now calculate, like and so on will be there. So it will be 8K comma 32K. This will be 52K comma minus means 28K, like and so on you will get. This is passed through what? Passed through ideal low pass filter, cutoff frequency 15K only. Means it allows all the components up to 15K. If you see up to 15K, what is available? 12K as well as 8K. And remaining all are, if you go, will be greater than that. So 12 and 8. 12 and 8 means option D. Simple 2 marks question. The thing you need to remember, these are the frequency components available at the output of a sampled signal. After taking that, whether they will give you low pass or high pass or maybe band pass, depending upon that, take the components. See the next problem. at a given probability of error, binary coherent FSK is inferior to binary coherent PSK. Given options are 3 dB, 6 dB, 0 dB, 2 dB. This is asking for 1 mark in the K 2002 examination. Let's see. What is this meaning here? Here, to understand this probability of error concept, you need to get back the distance between the signaling points, what I given in each and every modulation schemes. You can take as a sequence. First I discussed ASA, next PSK, next FSK I discussed. Here what is the distances are? The distance between the signaling points. Here is root EB, sir. What about here, sir? 2 times root EB, sir. What about in FSK? Will be root 2 times root EB. So probability of error we already know, directly proportional to 1 divided by distance. More distance, less error. Now he given in terms of decibels. Are you getting my point? The distance I written root of EB means in terms of voltage we written. So if you want in decibels, voltage means 20 log, power means 10 log. So for these you need to take in decibels means 20 log. When compared to PSK as well as FSK, how much distance more in PSK? Here 2, here root 2. So root 2 is more. So if you want to convert in decibels, 20 log root 2. Why? Because this is root of energy means voltage form. So 20 log root 2 means 3 dB. So I can say PSK is 3 dB superior when compared to FSK, or FSK is inferior to PSK by 3 dB. Now, these two also you can analyze. If you analyze those two times, so 20 log 2 is 6 dB. When compared to ASK, PSK is 6 dB superior, or PSK is 6 dB superior, or ASK is inferior to PSK by 6 dB. Or you can compare ASK and FSK root 2 times. So when compared to ASK, FSK is 3 dB superior, or ASK is 3 dB inferior to FSK. Now all the points based on the distance. So voltage form is 20 log you need to take. 20 log root 2 is 3 dB, 20 log 2 is 6 dB. So for the given problem is FSK inferior to PSK by 3 dB. That is asked. And remember the logics. Probability of error directly proportional 1 by distance. From the constellation diagrams we written. See the next problem. An interesting one. A sinusoidal signal with a peak-to-peak amplitude of 1.536 is quantized into 128 levels using mid-rise uniform quantizer. Like we are having two types, mid-thread, mid-rise. Mid-rise uniform quantizer, the quantization noise power is, he given options are, option A 0.768 volt, option B 48 into 10 power minus 6 whole square, option C 12 into 10 power minus 6 whole square, option D 3.072 volt. So by seeing the options itself, 2 we can avoid, because noise power means whole square, it will be there, either B or C. That is 48 or 12. This is asking in the GATE 2003 for 2 marks. Got my point? Yeah. Here, what is asking? Quantization noise power. Quantization noise power means NQ. What is that NQ value, sir? NQ value is del square by 12, sir. Delta square by 12. What is the delta formula? V peak to peak by 2 power n, or L. V peak to peak amplitude how much given? 1.536 by V peak to peak by L. L is given 128 whole square divided by 12. After doing this, most of the students what will do is, in the urgently opening the virtual calculator, they are typing and doing, and they are wasting their time. Before going into calculator, are you listening my words? Concentrate here. So before you are going for calculator, use your mind just once. Don't waste your time in the virtual calculator. Use your mind. Presence of mind is important. So here, simply if you see here, you can feel this is 1536. So 3 points we are avoiding means 10 power 3 in the square means comes outside means 10 power minus 6. Because these are 3 points I am eliminating. And you can say 120 once 128, remaining will be 25, 6 is there. So 256. 128, 2s are 256. So 128 12s will be 1356. So what is remaining here? 12 square. 12 square means 12 into 12. 112 is there in the denominator, gone. Remaining is 12 into 10 power minus 6. Power means whole square. Then you can see the options. Option C is the correct one. See how beautifully we solved this problem. So try to use your mind. So try these type of problems. So keep concentrate. When here gate problem solving is not only the solution. Solution you can get anywhere. But the way of styling or analyzing the problem, solving the problem, bringing the final result is the most important. That procedure you need to understand, students. So for that logic simple, given for 2 marks. See the next problem. If EB, the energy per bit of a binary digital signal is 10 power minus 5 watt second. Energy means watt second. And one side the power spectral density of a white noise is 10 power minus 6 watt per H. That is watt per second. The output SNR of the matched filter is asking what SNR means, signal to noise ratio. Simple problem. What is signal to noise ratio is nothing but signal power to noise power. Signal power to noise power. And here the point you need to understand, what is the noise power? Noise power will be maximized to N0 by 2 if you are using the matched filter. So this noise power is N0 by 2. In place of signal power he given EB. This is also in terms of power spectral density, both will cancel. What then it is becoming as 2 EB by N0. Recently also this 17 or 18 the problem also same repeated model came. So 2 into what is the EB value? 10 power minus 5 divided by N0, 10 power minus 6. Then it comes to the numerator, how much it will be? 20. But the options are given decibels na. So that to signal to noise power na. Power means 10 log. So 10 log 20 is nothing but 13 dB, sir. So which option? You can take the option D. Simple question. Only the logic you need to understand. The output of a matched filter is maximized to N0 by 2. N is maximized to N0 by 2. Actually N formula is this N0 B. B is the bandwidth. But if you are using the matched filter, this power is maximized to N0 by B itself, where N0 is the power spectral density. And he given already one-sided means directly given is N0. If they are saying two-sided means given is N0 by 2, from there calculate N0. See the next problem. This is on the delta modulation. The input to a linear delta modulator having a step size delta equal to 0.628 volt is a sine wave with peak amplitude AM and a frequency FM. If the sampling frequency Fs 40K, the combination of the amplitude and the frequency of a sine wave where slope overload will take place. So in the delta modulation we are having two errors, slope overload as well as granular error or idling error. So what is the condition for slope overload error for sinusoidal signals? That is nothing but delta by Ts is less than 2 pi AM FM. For granular errors, delta by Ts greater than 2 pi AM FM. And here, slope overload takes place means this condition has to obey. What is the combination of that AM and FM is asking, where delta and Ts values are given. He given options AM and FM in kilohertz. Option A 0.38, option B 1.54, option C 1.52, option D 3.1. This is asking for 2 marks in GATE 2003 exam. One of the important model. Slope overload takes place means that condition is obeyed. Granular error takes place means that condition is obeyed. Granular error means greater than, you need to write. What is the delta value given, sir? 0.628 into 1 by TS will be Fs. What is the Fs given, sir? 40K less than 2 pi AM FM. For 10 keep here. So 6.28 into 4K should be less than 2 pi AM FM. So 2 pi 6.28 gone. Remaining is 4K is less than AM FM. Let's take the combination of AM and FM where this condition obeyed. See the first option. 0.8 into 0.3 into 8 will be 2.4K because FM in kilo. 4K never be less than 2.4K. Leave it. See the second option. 1.5 into 4 will be 6. So 6K. 4K will never be less than, 4K is less than 6K. 4K less than 6K means valid option only. Remaining you can take 1.5 into 2, 3K. 4K never be less than 3K. Here also 4K never be less than 3K. So option B is the correct one. Got my point or not? So here, slope overload takes place means this condition obeying. What is the combination of AM and FM is asking. A simple question. By remembering the condition itself, you will get the 2 marks. So total I discussed 6 conditions in the delta modulation. 3 for general messages, another 3 for sinusoidal messages. So that you need to remember. One is for no errors, means optimum value calculation of step size, slope overload error, granular error. Total 3 in 2 sets. One is for general message, another is for sinusoidal. See the next problem. If S represents the carrier synchronous at the receiver and P represents the bandwidth efficiency, then the correct statement for coherent binary PSK is. He given 4 options. Option A, P equal to 0.5, S is required. Second option, P equal to 1.0, S is required. Option C, P equal to 0.5, S is not required. Option D, P equal to 1.0, S is not required. We already knows that for a coherent binary PSK, synchronization is need. So synchronization is required. To avoid the difficulty itself, we are going into a DPSK. Anyhow, in binary PSK, synchronization required. So S is required. And what is P, sir? P is saying about the bandwidth efficiency. What is the bandwidth efficiency, sir? Bandwidth is efficiency is nothing but RB by bandwidth of that signal. RB by bandwidth of that signal. So RB by what is the bandwidth, sir? Bandwidth is 2RP. It is nothing but 0.5. Some of the books are given some different opinions, but my answer will be bandwidth efficiency means RB by bandwidth. It will be 0.5. Clear? So the answer is option A. That is the correct one. Maybe different books are given different institutions, but this is the correct answer in my opinion. See the next problem. A signal is sampled. A signal is sampled at 8K and quantized using 8-bit quantizer. 8-bit uniform quantizer. Assuming SNR for a sinusoidal signal, the correct statement for PCM signal with bitrate of R is given options. R equal to 32 kbps, SNR is 25.8 dB. Second option, R equal to 64 kbps, SNR is 49.8 dB. Third option, R equal to 64 kbps, SNR is 55.8 dB. Option D, R equal to 32 kbps, SNR is 49.8 dB. This is asking in the 2003 GATE examination for 2 marks. In 3, there are number of questions came. In overall, you can check in analog, digital, random variable information, in all the topics, more number of questions came. Almost of 25 to 26 marks came. Only in the communication system. Now, we already know what is a bitrate. R equal to, R is nothing but NFS. Simple logic. What is the N values are? 8-bit PCM system. What is FSSR? Is 8K. So it will be 64 kbps. One question done. What is the second one, sir? Is asking signal to noise ratio, sinusoidal signal. What is the SNR value? Of course, SNR Q, signal to noise ratio, means quantization Q meaning here. That is 1.8 plus 6 in decibels. 1.8 plus 6 into what's the N values are? 8. So 6 8s are 48. So 49.8 decibels. Now you can check. R value 64, SNR is 49.8 dB. So option B. Regular models of asking these questions from bit rate and SNR value. Mostly they will ask for sinusoidal or maybe rare case uniform distribution. See the next problem. In a PCM system, if the code word length is increasing from 6 to 8, the signal to quantization noise ratio improves by a factor. Option A 8 by 6, option B 12, option C 16, option D 8. This is a problem asking in the 2004 GATE examination for 1 mark. So we already know what is the improvement factor for signal to noise ratio. If k bits are increased, I told 2 power 2k. Here the number of bits are increasing from 6 to 8 means, 6 to 8 means how many bits increases? 2 bits increases. If k bits increases, 2 power 2k times 2 bits increases means 2 power 2 into 2. So 2 power 4, so 16 times will be the improvement factor. Number of times this question came. Here this also I derived. So if the signal to, if the number of bits are increasing from n to n plus k, the signal to noise ratio increases by 2 power 2k times. In terms of decibel, 6k decibel. But normal value given means 2 power 2k, I substituted 2 power 16, 2 power 4 means 16 we got. See the next problem. In the output of a DM means delta modulator speech encoder, the consecutive pulse are of opposite polarity during the interval some T1 to T2. This indicates that during that interval, option A, the input to the modulator is essentially constant. Option B, the modulator is going through slope overload. Option C, the accumulator is in saturation. Option D, the speech signal being sampled at the Nyquist rate. This is given the GATE 2004 examination for 1 mark. What he is saying, sir? Pulses of opposite polarity means here what is happening delta modulation? For example, if a signal is almost constant, what is happening? What is happening in delta modulation? Negative pulse, positive pulse, negative pulse, positive pulse, like that. Why? Because this, we already, the step size is constant, we keep. Because of that, if signal is constant, what we are approximation is coming like this, he told. This type of approximation is coming because the signal will go into a granular error or idling error. When this is happening, opposite polarities, when the signal is constant, but we are giving the opposite polarity, pulses they are giving. So signal must be essentially a constant to the modulator. In that situation, granular errors also will come. This type is itself is called granular error. So option A is the correct answer. See the next problem. A source produces binary data at a rate of 10 kbps, means RB value given. The binary symbols are represented as shown below. 1 with the positive pulse, 0 with the negative pulse, means we are using NRZ signaling scheme. The source output is transmitted using 2 modulation schemes, namely PSK and QPSK. Let a B1, B2 be the bandwidth requirements of PSK and QPSK respectively, assuming that the bandwidths of the above rectangular pulses are 10 kilo. B1 and B2 are, where B1 is the for PSK, B2 is the QPSK. The given options are option A, B1 equal to 20k and B2 is 20k. Option B, B1 is 10k, B2 is 20k. Option C, B1 is 20k and B2 is 10k. Option D, B1 is 10k, B2 is 10k. This is a question asking in the GATE examination 2004 for 2 marks. We already know what is the bandwidth formula for PSK. The bandwidth formula for PSK is, students, 2RB. We discussed it in the binary schemes. RB is 10k, so 2 tens are 20k. So B1 value is 20k. And what is B2 means QPSK. What is the common formula for bandwidth of MLA signaling schemes I given? 2 by NTB. That is 2RB by N. N means number of bits transmitting at a time. In QPSK, N value is 2. So 2 bits we are sending at a time. Of course, quadrature phase between the symbols 0, 0, 0, 1, 1, 0, 1, 1. So what is that value becoming? RB. What is the RB value given, students? 10k. That is nothing but B2. So B1 is 20, B2 is 10k. See the option? B1 is 20k, B2 is 10k. So option C is the correct answer. This is the bandwidth formula for PSK schemes, and this is for any modulation schemes, MRA schemes, even for the binary also. But I given binary starting means I am writing separately. So for binary PSK means N value 1, so it's becoming as 2RP. N means number of bits transmitting at a time. M means maximum possible number of symbols. See our class on the MRA signaling schemes also. Clear? See the next problem. One of the important model on the probability of error. Consider a binary digital communication system with equally likely zeros and ones. Means probability of transmission of 0 and 1 is same. Both are same means 1 by 2, 1 by 2. When binary 0 is transmitted, the detector input can lie between minus 0.25 to plus 0.25 with equal probability. When binary 1 is transmitted, detector input can lie between 0 and 1 with equal probability. 0 and 1 with equal probability. Threshold is 0.2. Then average bit error rate means, what is the meaning of average bit error rate? Average bit error rate or average bit error rate or probability of error, anything is same. Average bit error rate is nothing but PE0 plus PE1 divided by 2. The average. Actually, what is bit error rate? Bit error rate is nothing but probability of 0 into probability of error for 0. Probability of 1 into probability of error for 1. Here equally likely means probability of error for 0 and 1 both are same. So 1 by 2, 1 by 2. Got my point? So that is also equal to average bit error rate. If probability for 0 and 1 same, transmitted probability same means bit error rate also equal to average bit error rate. And here, when 0 is transmitted, detector input lying between minus 0.25 to plus 0.25. Meaning is, if I draw the PDF for the probability of or the transmission of 0, you can say take as a P0, as well as P1 is the PDF function for the, you can take for the 1. When 0 transmitted lies between where to where, sir? It lies between minus 0.25 to plus 0.25. Let's take any variable. Let's take Z is our random variable. And what is that value? This value 1 divided by upper minus lower limit, or total area should be equal to 1. Anything you can take 1 by 0.5. So when 1 is transmitted, it lies between 0 to 1. So 1 by upper minus lower limit will be that amplitude, and total area should be 1. Now calculate probability error for 0 as well as 1. So probability of error for 0 is nothing but, when probability of error for 0 you will get whenever input is greater than threshold. If input crossing the threshold, it will treat as a 1, means I 0 transmitted treating as 1. So probability of error for 0 means, in the calculations we seen, input greater than the threshold. means integrate from threshold to infinite. Are you getting my point? So threshold is 0.2 to infinite, but it's existing only up to 0.25 into what is this value? 1 by 0.5 means 2. Are you following my point or not? 1 by 0.5 means 2 into what is this value from 0.2 to 0.25 is 2 into dz. Then what is this value? 2 is a constant outside. dz is z. Upper minus lower limit. Upper limit is 0.25 minus lower limit is 0.2. So 0.05. Then what is that value is 0.1. Next comes to here. What is the probability of error for 1? Probability of error for 1 means whenever input is less than threshold means probability of input is less than threshold. P of we have to write. But for your understanding I am writing. Means where to where it I have to integrate? Minus infinite to threshold and its PDF into dz. Its PDF value is of course 1 into dz. But it is starting from also 0 only. So what is this value? 0.2 dz is z. Upper minus lower limit 1 into 0.2 minus 0. So it will be 0.2. Now he is asking average bit error rate now. So substitute here the both values. PE1, PE0 is 0.1, PE1 is 0.2 divided by 2, 0.3 by 2, so 0.15. 0.15 means option A. And here, try to understand, I take an equal probability because he given when 0 transmitted lies between minus 0.25 to plus 0.5 with equal probability. Here, 0 to 1 with equal probability. So I taken uniform PDFs. And the total area under the PDF should be 1 because total area under the PDF is nothing but total probability. All these points we already known. So average bit error rate, average I take. Got my point? So option A 0.15. 0.15 is the correct answer. See the next problem. Choose the correct one among the alternatives A, B, C, D after matching an item group 1 with the group 2. Group 1 given 1 FM, 2 delta modulation, 3 phase shift keying, 4 pulse code modulation. Group 2 P slow power load, Q Mueller, R envelope detector, S capture effect, T Hilbert transform, U matched filter. And given options A, B, C, D like that they given. This is asking in the GATE 2004 for 2 marks. We already known frequency modulation among all the given will be matching to the capture effect. What is the capture effect in FM? One of the important. For example, if 2 stations are available, so 2 stations meaning is, suppose I am at Hyderabad. Hyderabad station of 93.5 is available here with more strength. Another station from adjacent city 98.3 or 93.5 available. Both are same frequency. One is from Hyderabad, another is from another city. If both are available, always FM will capture the strength 1. If 2 stations of same frequency available also, always it captures the strength 1. That is the capture effect. That is one of the thing of FM. But in AM, both mixing will come. But in FM, only the strongest signal will come. If both are fluctuate, FM also fluctuate between those two. So FM is capture effect. Next, delta modulation. We already seen. In delta modulation, slow power load, granular error. Granular error also called idling error. PSK demodulation will be matched filter. And coming to the PCM, ALA and MULA non-uniform quantization techniques are there. Non-uniform quantization techniques ALA and MULA. So PCM means MULA. Then you can see FM is capture effect. So 1 is yes. So in these 2. Delta modulation is slow power load, so 2 is P, obviously this. Third, PSK is matched filter, PCM is Mueller. So option Q na? So option C is the correct one. Are you getting the point or not? So this is simple for 2 marks question. Clear? Yeah. See the next problem. 3 analog signals having the bandwidths 1200, 600 and 600 are sample at their respective Nyquist rates, encoded with 12-bit watts and a time division multiplexed. The bit rate for the following multiplexed signal is option A 115 means 115.2 kbps, 28.8 kbps, option C 57.6, option D 38.4 kbps. It's a regular model from the TDM. What is the bit rate is asking. Bit rate RB equal to formula is capital N small n into Fs. Here small n into, I can say Fs1 plus Fs2 plus Fs3 because all are given different bandwidths. So n is given a 12-bit word. So 12 into Fs1, 2 times of their value because Nyquist rate he told. So 2 into 600, third one also 2 into 600. This calculated 4.8 into 12. So we'll get 57.6 kbps. A regular model. This is if all are having same bandwidth means same sampling rate will come, different means different intake. Sometimes small n value may given or not given. If not given, 1. But he given 12-bit words, so 12. See the next problem on the matched filter. Consider the signal x of t shown in the figure. Let h of t denotes the impulse response of the filter matched to the input x of t. With h of t is non-zero only in the interval 0 to 4 seconds. The slope of the h of t in the interval 3 to 4 seconds is, this is the x of t given and he given the options. Option A 1/2 second inverse, option B -1 second inverse, option C -1/2 second inverse, option D 1 second inverse. This is asking in the GATE 2004 examination for 2 marks students. So what he is asking, h of t slope in the interval 3 to 4 is asking. What is the h of t impulse response of the matched filter? It's already input is matched. So what is the h of t, sir? H of t is nothing but x of capital T minus small t, where capital T is the duration of the input is 4, so 4 minus t. That we need to calculate. You got my point. So how to calculate this, sir? Minus t plus 4. First make the plus 4 operation and then go for the reversal, that is minus t. How to get plus 4 advanced operation, sir? Subtract 4 from the all t values. So first I am calculating x of t plus 4. So how to do? Subtract 4 from all the t values. 0 minus 4 is minus 4. 1 minus 4 minus 3. 2 minus 4 minus 2. 3 minus 4 minus 1. 4 minus 4 0. The same shapes. What is preserved from 0 to 1 now will be at minus 4 to minus 3, like and so on. 0 to 1 it's a shape. Next 1 to 2. Next 2 to 3. Next 3 to 4, the same thing will be preserved. 1 below will be minus 1. Now to get the h of t. Now what is h of t? Will be minus t plus 4. So go for the minus t operation. How to get the minus t operation? Multiply all t values by negative sign. Minus 4 will become plus 4. Minus 3 will become plus 3. Minus 2 will become plus 2. Minus 1 will become plus 1. 0 will be 0 only. Minus 4 is becoming plus 4. Minus 3 becoming plus 3. The shape from here to here will comes this side. So how 4 from 4 to minus 3, minus 4 to minus 3 increasing, the same thing. Next 3 to 2 will be decreasing. 2 to 1 increasing. Then constant like that. This is 1, below will be minus 1. Where to where is asking the slope? 3 to 4. Decreasing now. 3 to 4. See from 3 to 4. 3 to 4 decreasing means obviously negative. What is the slope? Change in y by change in x. Change in y is 1. Change in x also 1. So 1, but decreasing means minus 1. Obviously the denominator second means second inverse. So minus 1 second inverse. Minus 1 second inverse means see the options. Option B is the correct one. Simple here, making the time operations only. Because the impulse response of matched filter is x of t minus small t, where t, capital T is the duration, x of t is the input. Simple logic only. See the next problem. A signal shown in the figure is applied to a matched filter. Calculate the output of the matched filter. We already know what is the output of any system. Input convolution with the impulse response. Here what is the impulse response? If you call impulse response is h of t. If you are calling input is some x of t. H of t is nothing but x of capital T minus small t, where capital T the duration of the input, that is nothing but 2 seconds. First draw the signal and make the convolution between the both, you will get the output. So for this one, first calculate x of t plus 2. How to get a plus operations? Subtract 2 from all the t values. So 0 minus 2 is minus 2, 1 minus 2, minus 1, 2 minus 2, 0. The same shape. So 0 will be at minus 2, 1, minus. Next calculate h of t. H of t is nothing but x of minus t plus 2. Draw that signal. Then it will be multiply all t values with the minus sign. Minus 2 will be plus 2, minus 1 will be plus 1. So the shape will comes here. So minus 2 to minus 1 positive. 1 minus. Got my point? Now we need to make the convolution of these two. So to make the convolution, the better option is the signal, any signal you can, not any signal, this signal you can represent with the step signals because it is having step variation. Where is the step variation starting from 0? Starting from 0 means u of t. And at t equal to 1, another step change. How much change? Minus 2. Where? At 1. So u of t minus 1. Next change, how much? Final minus initial. So minus 1 into u of where? T minus 2. Like write the h of t also. Minus u of t plus 2 into u of t minus 1. Minus 1 into u of t minus 2. Wherever is the change, write the step signal at those instants. Change means final minus initial value. Means always right side value minus left side value at that instant. Make the convolution between the both. Convolution of two step signals will be nothing but a ramp signal. So output y of t equal to these two convolution. Plus into minus minus r of t. Plus into plus plus 2 into r of t minus 1. Plus into minus minus r of t minus 2. Next, minus into minus plus r of t minus 1. The same delays will be going to be adding. Next, minus into plus minus 4 r of t minus 1 minus 1 t minus 2. Minus into minus plus r of t minus 2 minus 1 minus 3. Next, minus into minus plus r of t minus 2 minus 2 into r of t minus 1 minus into minus plus r of t minus 4. 1 second. 2 into 1, this will be 3. Add the similar ones. Then minus r of t. Minus 1, so how many is there? 2 plus 1, 3. So plus 3 r of t minus 1. 2, so how many will be there? Minus 1, minus 4. Minus 5 plus 1. So minus 4 r of t minus 2. Plus 1, minus 2. So minus r of t minus 3 plus r of t minus 4. Now draw the signal, student. From where to where? 0 to 4. You can take 1, this is 2, minus 1 like that. So starting from 0, r of t negative slope. This is 1 you can take. At 1, how much is the change happened? 3 happened. Total change is 3. Total change is nothing but 3. Change means initial minus final value is 3. Initial slope is minus 1. So, sorry, I written wrong. Final minus initial is 3. Initial slope is minus 1. Are you getting my point? So, minus of minus plus 1. Getting my point? So, plus 1 comes this side, minus 1. So, final, it is increasing up to 2. So, with a slope of 2, 1, 2, 3, 4. Now the 1 to 2, its slope is 2. So 2 units it will rise. Already it is at minus 1. 2 units means final slope 2 units means it comes up to 2. See, final slope minus initial slope. All these will give you the slopes. Next, what happened at 4? Minus 4 is adding. Are you getting me? So, total these coefficients will indicate the slopes. These coefficients will indicate the amplitudes. What is the final slope change? Slope change is minus 4. Initial means this previous one is 2. So, it will become minus 2. So, it is decreasing. And then at a 3 another minus. So previously minus 2, so it goes with the minus 1. And at 4 is adding, plus 1 is adding, so it's becoming as 0. So now if you want, you can check. At a minus 1, what should be the slope change? Final minus initial. Final is 2, it's a slope. Initial is 1, minus 1. So minus 2, minus of, 2 minus of minus 1 is plus 1, 2 plus 1, 3. So all these coefficients will indicate the slopes. So this is the output y of t. It's just like a normal problem with the more calculations only. Clear?